Alright guys, in this lesson we'll be writing linear equations in various forms. Once again, let's revisit. Linear equation in two variables is a relationship with a constant rate of change, represented by a graph that forms a straight line. So again, we're still looking at linear equations, so graphs that make straight lines. Various forms of linear equations in two variables. We got the slope-intercept form, which is the most common form that we teach over and over again, where we get y equals mx plus b. Of course, m is our slope or our rate of change, and b is the y-intercept. Once again, our y-intercept is that point where x is 0, and then we get some value for the y. Point slope form. We have y minus y1 equals m times x minus x1. Well, once again, m is the slope. The same thing. If you know how to find the slope for slope-intercept form, you know how to find it for point slope form. And x1, y1 is a given point. This usually tends to confuse students, but what it's doing is just naming the point and any given point. So you can have a table of values, and you can choose any of those points that you want, but it's just a given point. You're just going to plug those in. So you know this x1 will go right there, and that y1 will go right in there. Okay, but that's the form we use: y minus y1 equals m times x minus x1. We got our standard form, where it's ax plus by equals c. That's the traditional format, and a, b, and c have to be an element of the integers. Remember, the z represents integers, and what we're pretty much stating there is it cannot be the number in front of the x and the number in front of the b, and the c cannot be fractional or decimal. And also a has to be greater than or equal to 0. So once again, if a is a negative number, we're going to have to fix that as well. X and y terms are on one side of the equation and the constant is on the other. So to be in standard form, it has to have a couple of things. Once again, we got to get the ax, or the x and the y terms on one side of the equation. A, b, and c have to be integers, and the a has to be greater than or equal to 0. Okay. Once again, we got rate of change by various methods. We've gone over this over and over again. That's a big thing to hit because, once again, to find our slope, we got our change in y values over the change in x values. Once again, this is saying the same thing. Triangles represent this guy, change in, so change in y over the change in x. And of course, this is pretty much saying the same thing, but we're just giving you a formula to use where m equals y2 minus y1 over x2 minus x1. Once again, this is just naming some points that are given to you, and you can plug them in if you want. But those are your different ways. If you have a graph, you can do slope equals rise over run. Pretty simple way. Algebraically, if it's already written like this for you, or even point slope form, you know your slope's already given to you right there. Alright, so I'm going to go over down here. Problem number 1 says find an equation in point slope form. Remember, that's that. We'll go down a little bit. Well, let me see here. Let's write it right here. So we want an equation of point slope form, or the y equals mx plus b form. Okay. Sorry, my writing's a little sloppy. All right. Pen doesn't like me too much. All right. So we want that form. We want slope. Oh, sorry. That's not point slope form. That is slope intercept form. All right. And once again, point slope form. That's that y minus y1 equals m times x minus x1. Okay. That's our point slope form. We also want in slope intercept form. So that's our y equals mx plus b. And lastly, we also want in standard form. Okay, so standard form, of course, is ax plus by equals c. So sometimes the easiest way to go is go ahead and put in this point slope form. Unless, of course, they give you the y-intercept right away. In this case, they didn't. They gave us the slope of negative 3/5, and it passes through the point negative 5, 11. So that's our given point. Once again, the 11 is our y value, and the negative 5 is our x value. So in this case, this is only given point, so we can pretty much name that 11 our y1, and then negative 5 our x1, and plug it in to this point slope form. So we can go y. Let me see, we're going to plug in that 11 for the y1, so minus. Once again, got to follow the formula to say minus, so minus 11 equals m, which of course we're given the slope, which is m is negative 3/5, so negative 3/5 times x minus that given x value of negative 5, so minus a negative 5. Go ahead and rewrite this as y minus 11 equals negative 3/5 times x, and minus a negative 5, of course, because minus a negative is a positive, so plus 5. Okay. So that is our point slope form of the equation. And that's it. Just plug in the point, plug in the slope if it's given to you. Okay. Now let's look at this. Y equals mx plus b. Okay, so what we can do is we can use our point slope form and make it look like this. So from here, what I can do to make it look like that is I can distribute out that slope. What I mean by distribute is multiply. Take that negative 3/5, multiply to that x, take it again and multiply to that positive 5. So when we distribute first, we get y minus 11 equals, well, negative 3/5 times x, which is negative 3/5 x, and a negative 3/5 times that positive 5 now. Well, negative times a positive is a negative, and 3/5 times 5 becomes 3. Okay, well, the last thing to make it look like slope-intercept form is we got to solve for that y, so we got to bring that 11 over. So it says minus 11, so in order to get rid of that minus 11, we're going to have to add 11. I'll do the opposite of what it says. So instead of subtracting, we're going to add. So we're going to add what we do to one side, though, make sure we do to the other side. So we did it to that side, we're going to do it to this side, so we're going to add 11. Okay, so then get y, and of course negative 11 plus 11 is 0, so those go disappear, equals negative 3/5 x, and a negative 3 plus 11 is plus 8. So we get y equals negative 3/5 x plus 8, and there is our slope-intercept form, where negative 3/5 is our slope and 8 is our y-intercept. Okay, so once again, to reiterate, we plugged it in, our point and our slope, and that's what we got for point slope form. We solved for y, and we got that for our slope-intercept form. Lastly, we want to do standard form. Okay, there's a couple of different paths. You can take a couple of different steps. My favorite one always is to go ahead and get rid of these fractions, because once again, the number in front of the x and the number in front of the y, and of course the c, all have to be integers, or they can't be fractions, they can't be decimals. Well, the easiest way to get rid of it, we can see the only fraction that we have is this negative 3/5. So in order to get rid of a fraction, what we can do is multiply by the denominator of that fraction. If we had more fractions, we'd have to find the common denominator of all those fractions. Well, in this case, it's just 5. So I can take this and multiply everybody by 5. And when I do that, I take 5 times y, get 5y, equals, well, 5 times is negative 3/5 x. And of course, the reason why I like doing that is because that 5 right here will kill the 5 at the bottom. So we're just left with that negative 3. So we get negative 3x. And then, of course, take that 5 now and then multiply it to that 8. And 5 times 8 becomes 40. Okay? So we can see, and I'm going to take this over here in a second. Still doesn't look like that because we don't have our x in the front. So we need to take it to the other side of the equation. Pretty easy to do, though. Give myself some room here. We're going to go 5y equals negative 3x. Just bringing it over. Give myself a little bit of room. Plus 40. Okay, so like I said, we need to bring that negative 3x to the other side. Well, since it's a negative 3x, and we want to bring that whole term over to the other side, well, let's do the opposite of what negative 3x is, which is adding 3x. So So plus 3x. And once again, since I'm doing it to this side, I must do it to the other side. And let's see here. 3x and 5y, they're not like terms, so we can't combine them together. So let's just bring them down. We got a positive 3x now over here, coming down. Bringing that positive 5y down, so plus 5y equals, well, of course these killed each other, and we're just going to bring that 40 down since it didn't combine with anybody. Okay, so now it looks like we have ax, or 3x, plus by, or 5y, equals our c, or 40. So this does look in standard form. And it does follow all the rules, where everything is an integer. Our a, our b, and our c has 3, 5, and 40. Those are integers. And our a is greater than or equal to 1. It is greater than 1 as a 3. So here's our standard form of the equation. Okay, that solves that one. Move on down to the next one. It says find an equation of point-slope form, slope-intercept form, and standard form of an equation that passes through the points -6, 2, and 6, 7. Okay, this one's different than the other problem that we're given, as we're not given the slope, so we need to go find the slope. In this case, probably the easiest way is to go ahead and do the m equals y2 minus y1 over x2 minus x1. Okay, once again, those y2s and y1s are just naming the points, and it's up to you. You can name this guy your 2 points or your 1 points, and same with this. It doesn't matter, but just name them opposite. So I'm going to go ahead and, like I said, it doesn't matter. I'm going to name these guys my 2's. So I'm going to call him x2 comma y2, and then this guy over here is my x1 comma y1. Plugging in purpose. Like I said, it doesn't matter. I just made that decision. So we're going to get m equals, all right, y2. Like I said, we're naming that 2 the y2, so go ahead and put 2 down. Minus, follow the formula, y1. And y1 we named as 7, so 7. Over my x2 I named as a -6, so -6. And of course minus, following the formula, minus my x1, which I named as 6. So 6. Okay, and solving that, we got 2 minus 7. Once again, you don't have to use mental math, use a calculator if you need one, but it'll be -5 over, well, -6 minus 6. Well, that becomes -12. Let's see if we can simplify this down. Well, 5 over 12, there's no common multiple, so we can't simplify that fraction down. So, but a negative divided by negative is a positive, so our slope does become 5 over 12. Okay, so I'm going to write that down over here somewhere. I'm going to get rid of this stuff. Give myself a little bit more room. I'm going to write down, now we know our slope, or our m, is equal to 5 over 12. Okay, so like we did before in the previous problem, to find my point slope form, we're going to go y minus y1 equals m times x minus x1. You remember the definition that said any given point, so it doesn't matter whether I use this point or this point right here. Doesn't matter. I can call one the x1 y1, or once again you're going to get the same result. And I mean, it looks different, but at the end of the day, when you try to solve in slope intercept form, you're going to get the same result. I'm going to show you using both and go ahead and solve both and make it a slope intercept form. And I know it'll be might be a little tedious, but I just want you to see that both will result in the same when you transfer it to slope intercept form. So right now I'm going to go ahead and call the -6, 2 my x1 y1. So I'm going to go y minus, okay, make sure we get the y value, so the 2 equals m times x minus, make sure we get that x, so a -6. And of course, I'm going to rewrite this as y minus 2 equals, I'm sorry, m. I should have replaced that m in, which was 5 over 12. Sorry, I didn't do that before. I'll go to do that now, 5 over 12. Should have done that before, but that's fine. X. And minus a negative, of course, becomes a positive 6, so plus 6. Okay, just rewriting it real quick. All right, so that's 1 in point slope form. Let's look at the other one using the other point. So this time I'm going to use that 6, 7. So I'm going to go y. Let me make sure I give myself enough room. I'm going to go y minus. Okay, once again we're using that y minus y1 equals m times x minus x1. So this time I'm going to let my y1 be that 7. So minus 7 equals m. Of course, m is our 5 over 12 times x minus x1. We're letting x1 now be 6. Okay, and there's nothing more to do because minus 7 minus 6 it doesn't become minus a negative, so nothing else we need to do here. So there's both. They do kind of look different. Notice they do look different, but like I said, I'm going to solve both of these and put them in slope-intercept form. You don't have to do both. Just choose one or the other. I'm just showing you that they both will result in the same answer. Okay, but either one of these suffices for point-slope form for an answer choice. But real quick, let's solve these for y, so we can put it in point-slope form. And let me scroll down a little bit. Okay, so once again to solve, first thing we're going to do is distribute that slope. Let's get into multiply. So 5/12 times x, of course, is 5/12 x. And 5/12 times 6, so that becomes, let me see, make sure I do my math right. I believe it's 2.5. 30 divided by 12, just double checking myself. 30 over 12, yeah, 5 over 2 or 2.5. I'm going to go ahead and call it just 5 over 2. Since we got everything else in fractions right now. Okay, well, lastly, to solve for that y, we need to bring that positive 2 over. So add 2. And of course, we're going to add it with the other constant over here. And once again, remember, what you do to one side, you must do the other. Since it was a minus 2, we need to add 2 to get rid of that minus 2. And solving it, we get y equals, let's kill each other, 5 over 12x. And 5 over 2 plus 2 becomes, well, this is the same thing as writing 4 over 2. So 5 plus 4 is 9. So we get plus 9 over 2. Okay, well, what about the other guy? Well, let's see here. Once again, let's distribute out that 5 over 12 to both of these guys. So we get 5 over 12x. And 5/12 times a negative 6. Same thing, kind of like minus. Make sure I'm doing the math right. I don't want to mess up. Yeah, minus 5 over 2. Okay. Lastly, solve for that y. We're going to have to bring that negative 7 over. So since it's negative 7, the opposite of minus is adding. And what I do to one side, let's do it to the other. Once again, you can use a calculator, go negative 5 over 2 plus 7. But I'm going to do this mentally. That's the same thing as saying 14 over 2. Okay, so then we get y equals 5 over 12x. And negative 5 over 2 plus 7, well, negative 5. Yeah, negative 5 plus 14 becomes a 9. So plus 9 over 2. Notice how no matter which point I use, I still came up with the same thing for slope-intercept form. So there would be our slope-intercept form. I'm going to go ahead and keep this one. We did get the same answer. There we go. So to reiterate, once again, point-slope form, either one of these answers would have sufficed what we began with in the first place, because then when you transfer to slope-intercept form, you're going to get the same answer. It doesn't matter. Just choose your method. Just choose whatever point you want. Okay. I'm going to erase this real quick because lastly we got to put this in standard form. Hold on. Make sure we understand that this was one of our answers right here. So assuming you decide to go at that point. Alright, so lastly, to put in standard form, we need to first get rid of the fractions. Once again, you don't have to do that first, but I like to do that first. Okay. So I need to find a common multiple of 12 and 2, because those are my denominators. I want to get rid of those denominators. Well, common multiple of 12 and 2, of course, is 12. Because, you know, 2, 4, 6, 8, 10, 12. So if you multiply 2 by 6, you get 12. So 12 is a multiple of 2. And, of course, 12 is a multiple of itself. So let's go to multiply everybody by 12. Okay, well 12 times y becomes 12y. Let's take that 12 and multiply it to that 5 over 12. Once again, like I said, the great thing about this is this 12 will kill the denominator over here, so we're just left with that 5x. And then lastly, we'll take that 12 and multiply it to that 9 over 2. Once again, you can use a calculator. My favorite method is just go 12 divided by 2. I get 6. And take that 6 and multiply it to that 9. I get 54. That's how I do it in mental math. Okay, so far so good. Now, of course, remember standard form. Let me rewrite that down for you. AX plus BY equals C. That's standard form. That's what we're trying to get to. So we need to get the X terms and the Y terms on the same side. So in order to do that, we need to move this 5X to the other side. That whole term over. So to move all of him over, he's a positive 5x, so let's this time subtract out 5x. Because having 5x, subtracting 5x, we're going to get 0. We're just going to make it disappear on this right side and bring it over this left side. So of course, these aren't like terms, x and y's. So we're just going to bring these guys down as negative 5x plus 12y equals, once again, those disappear, we're left with 54. Okay, it does look like this format, but let's remember one rule. When you do have, it does look like that. All of our guys are integers, because negative 5, 12, and 54 are integers. Problem is our a is not greater than or equal to 0. It is actually less than. So we have to change this negative 5 to make it greater. Easy way to do that is just multiply everybody by negative 1. And when you do that, technically you're just changing everybody's sign. But to show you the math behind it, we're going to multiply everybody by negative 1. Because if I multiply everybody by negative 1, I still essentially get the same equation. I just need to make sure that a is positive. And since he's not positive, I'm going to multiply him by negative 1. Because a negative times negative gives me a positive. But like I said, it's just changing everybody's sign. But once again, if you distribute out that negative 1, 1 negative times a negative, it's a positive. 1 times 5x is just 5x. 5x. Negative 1 times a 12y, well, negative times a positive is a negative, and 1 times 12y is just 12y. And lastly, negative 1 times that 54, well, negative times a positive is a negative, and 1 times 54 is 54. So there's our equation in standard form. Okay, like I said, essentially it's just changing everybody's sign. He was a negative, now I made him a positive. The y was a positive, now I made him a negative. 54 was a positive, now I made him a negative. You only have to do that if the a is a negative. All right. Go down to the last one. This one's pretty easy. It says, what is an equation in slope-intercept form of a line that passes through the point 0, negative 4 and has a slope of negative 2/3? Okay, well, slope-intercept form. Y equals mx plus b. Where m, once again, is our slope. That's given to us right there. And our b is our y-intercept. Of course, our y-intercept is where x equals 0. What is our y value? Well, lo and behold, look at this. It gave it to us. Right there, our x is 0. So negative 4 is our y-intercept. We just need to plug that in. So y equals, well, plug in the slope. We get negative 2/3 x. And lastly, plug in that negative 4 in for the b, so minus 4. Alright, so there you go. There's our equation in slope-intercept form. Easy. Alright, one last thing I did want to go over with you guys, because I do get this question a lot. And we saw everything with standard form. With standard form, we had fractions. And some people ask me, well, Coach, what if I have a decimal? So I'm just going to give you an example here. Let's say we have y equals, I don't know, let's go 0.6x. Okay, and let's just say plus 3. Just making something up here. Okay, main thing is I want to tell you guys how to do something with that. Let me write this down real quick. Well, it really is your choice. My advice is if you can change that decimal to a fraction, that's the way I would go. You can write 0.6 as, sorry, that's the same thing as writing 6 over 10. Reduce down the fraction you get 3 over 5. Okay, that way you can have y equals 3 over 5x plus 3. 3/5 is the same thing as 0.6. So that doesn't really change anything. You're just rewriting it as a fraction. And now we can go the same method of multiplying by the denominator. You do have another choice, and the other choice is just to realize, well, if I'm going to get 0.6 to an integer, what do I got to multiply it by? Well, if I multiply 0.6 by 2, we get 1.2, so that's not far enough yet. So times 3 equals 1.8 times 4, you get 2.4 times 5, and then we get 3. And there is an integer, so you would have to multiply your whole equation by 5. But like I said, if you had already converted it to a fraction, you could have already seen, hey, we are multiplying by 5 because that is the denominator over here. All right, it's up to you, but I would usually try to convert it to a fraction if you can. All right, guys, well, that's today's lesson. Once again, check out the other resources if you need it, or look over this lesson again if you need any extra help. All right, y'all have a good day.